Hello and welcome to this video where I show you how I build a Raspberry Pi and Arduino to control a live streaming PTZ camera and the reason why I decided to build this project in the first place. Let me explain. So here I am in my church, and as you can see it's set up for social distancing. Normally a church is full of soft benches which can seat around 170, 180 people, but in this configuration we can only get in around 60. So like a lot of religious establishments around the world, we installed a live streaming camera. We purchased this Ava 520 back in the summer, and on the whole works really well. One of the reasons we bought it is because it has 10 preset camera positions, which can be configured by using remote control. With me standing here in front of the camera, the remote control works really well. However, during live streaming, the person controlling the live stream, which is normally me, sits right over the other side of the church on this table here. And the reason I have to do that is because I have to control the music, and our audio cabinet is just along, or the organ cabinet is just along there. Now if I pan back, look at the camera, that's about 12-13 metres away. And on a day like today, that's not too bad. The infrared will work. However, when the sun is shining, it's streaming through the stained glass windows, that signal can get distorted, which will either result in the camera not switching to the right location, or sometimes just even locks up, which can be very annoying for me, and a bit upsetting for the people watching also. So it got me thinking, there must be an easier way of getting this to work. I don't know if I can get maybe somehow put the remote control closer to the camera and try and remotely control the remote control, if that makes sense. Anyway, that's my problem. I'm going to go back home now, have a little think about it and see what I can come up with. Okay, I'm back home now in my office, home office, and on the way over here I was thinking how I want the interface to look. I want to try and get away from using this two-button approach to program the camera. At the moment, what I have to do is I have to press the program button and then one of the location keys, like for instance 1, and that sends out the relevant program code and the location code to the camera, and the camera switches position. That's fine, but I was thinking if I'm going to create a new interface for it, I want it to be a bit slicker than that. So what I'm going to use, I'm going to come up with a screen based, like either from a laptop or from an iPad. I think an iPad would probably be better. And then just program so I have the number of keys on the screen, and if I want to go to wide view, I just click on the wide view and that will send the program code followed by the location code. I think that will be a lot slicker, a lot easier to use. So that's my thinking. So whenever I have a technical problem of this nature, I always go to my go-to device, which is the Raspberry Pi. The Raspberry Pi, I love it because it's first of all, it's low cost. So it's a full-blown computer, single board computer. It has Wi-Fi, it has USB, LAN, Bluetooth support, and a number of GPIO pins. And most importantly, you can program it by using Python. Now, I've used the Raspberry Pis a lot over the last few years, and I know what they can do, and I know I can create a nice graphical user interface using Python. So that's what I'm thinking about doing, is to using a Raspberry Pi to give me a nice front end. But what I've never done, I've never used the Raspberry Pi to interface into an infrared device before. So I started doing some research on that, and to be honest, it can be done, but it is quite cumbersome. You have to download some libraries and set up a few settings, and the code is quite lengthy. But while I was doing research, I found a better way of doing it, and that's to use an Arduino. Now, I've worked on Arduinos in the past. I quite like them. They got their limitations, but it's also got their plus points. I mean, the limitation is that they don't have any Wi-Fi, so you can't Wi-Fi into them. And even if you could, you only really have a serial interface. You don't have like a graphical user interface that you can actually create on it, because really it's a controller. It's not a program. Having said that, I think you can get a Wi-Fi hat to fit on it somewhere, but that really wouldn't help me. But what your Arduino does do, it does handle infrared really well. I mean, it's got all these GPIO pins in here, but it has some pins that the Raspberry Pi doesn't have, and there's these analog ones. And there's a library that's been set up called RF Remote, and it really handles our infrared signaling really well. Not only sending but also receiving, and I'll show that in a minute, how we can use this to receive codes and also to send them, and with really just a few lines of code, and it's really quite impressive. Now, so that's the way I'm going to go. I'm going to use the Arduino to send out the infrared signals, and I'm going to use the Raspberry Pi to be the front end, the graphical user front end, but I need these two to talk to each other. Now, how am I going to do that? Well, you can connect USB cables to both and use a serial protocol, but that's a bit cumbersome. A much more elegant way is to use the I2C protocol, or sometimes known as the I2C. And basically it uses a data wire, a clock wire and a ground, just 3 wires, and then a little bit of coding, and you can get these two guys to talk to each other really well. Both the Raspberry Pi and the Arduino have built-in libraries to handle I2C, so there's no complicated downloads or anything like that. What you need to do on the Raspberry Pi, you do have to enable it. By default it's switched off, but that's just the button stroke. So yeah, so for the graphical user interface I'm going to use the Raspberry Pi, and for handling the infrared I'm going to use the Arduino. So this is my final solution. The camera, I'm going to put a little infrared sender right in front of the camera. An infrared sender is nothing more than a little LED sending out infrared light rather than visible light, connected to the Arduino. The Arduino will be connected to the Raspberry Pi by the I2C protocol. And the Raspberry Pi has some software in it called VNC. And what VNC allows you to do is allows you to use a laptop or even an iPad to VNC into the Raspberry Pi. So it's almost as though you've got a keyboard, screen and mouse connected to the Raspberry Pi, but it's virtual. So I'm using the screen, which is really the Raspberry Pi screen, and the keyboard on this lap, which is really the Raspberry Pi keyboard. It's a very clever piece of software. So I can press a button on the screen here, which really presses in the button on the software inside the Raspberry Pi, which will send a signal to the Arduino, which will send a signal to the RF sender, which will control the camera, and the camera will switch positions. So that's my solution. My next problem is, how do I find the codes that are inside this remote control to send to the camera? Now I need to find out which codes are, because I need to program them into the Raspberry Pi and the Arduino. So how am I going to do that? Well, I said before the Arduino has very good software when it comes to infrared, and one of them pieces of software is an infrared receiver, and with just a couple of lines of code and a receiver, RF receiver, I show you how we're going to find out all the codes that are inside this remote control. Okay, what I have here is a Arduino Uno connected to a infrared receiver. This particular model is a KY022. There are only a few pence on the internet. There's only 3 wires that you need to connect to get this to work, and the first one, the red wire, is the plus 5 volts, the black wire is the ground, and the green wire goes to digital pin 4. That's all you really need. I've also got a couple of infrared transmitters. One is from my television and one is from my skybox, and I've got the Arduino connected to my laptop with the serial monitor open. So what I'm going to do now, I'm going to send some signals by remote control to the Arduino. First of all, I'll use this remote control, which is a Samsung, and if I press it you'll see the light flash and it's receiving data. Now if I go back to my digital display, sorry, the serial display or serial monitor, if I press button 4, that's the code for button 4. Now you notice that it comes up with a header, which is the actual make. This is a Samsung, which is no surprising because my TV is a Samsung. I've also got a Sky remote control here. Now let me just clear the serial monitor for a second. Okay, and I'm going to now use the, I can't really show you, I'll zoom out a little bit. Well, let's do some codes first. So I'm pressing 1, 2, 3. Now you notice this is a Sky remote control, but the actual manufacturer code is RC6. And that's quite common. You quite often see remote controls that from third parties that are using different manufacturer codes, like for instance the Ava uses NEC. So yeah, it's very, very simple to set up. I'm going to go through the code now. Before I go through the Arduino sketch, I just want to give my thanks to a website or a YouTube site called the DroneBot Workshop, because if it hadn't been for them, I would never have been able to find this solution. The guy there called Bill has a number of YouTube videos. He normally focuses on the Raspberry Pi and the Arduinos. He does other stuff as well, but his videos are really precise and clear, and it's through him that I'm able to come up with this solution right now. In fact, this is his code in its entirety. I haven't modified this at all. But if you've not seen any of his videos, then I really encourage you to go and have a look at them. They're really good. I'll leave a link in the description below. But it's the DroneBot Workshop, and the guy there, I believe his name is Bill, is really good. Okay, so this is the script we're going to be using. It's fairly simple, really. But before we can use it, we need to download a library called IR Remote. So to do that, we need to go to Tools, and we need to go to Manage Library. And when a dialog box appears, we need to type in into the dialog box up here, we need to type in IR Remote. So that's capital I, capital R Remote. And it should appear somewhere. There it is, it's here. It appears in this area here. And you can see I've already got it installed. If you haven't got it installed, there's been an install button just here. Click on that. It takes about a couple of minutes to download, and then you're good to go. So let's go through the code as it is. It's fairly straightforward. Obviously, the first thing you need to do is to call in the library. Then you need to set a variable to the pin we're going to be using. So we're going to be using pin 4 to receive the data. Then we're going to enable the IF receiver as an object, and we're going to give it the variable receive underscore pin. And we're going to decode the results, so I'm going to use the variable results for that. Next, we're going to set up the serial monitor, and we're going to enable the IR receiver. Now, this is the loop. This is the thing that does everything. So we look at the results that's been decoded up here, and we print the results to the serial monitor in a hex format. And then we use this switch case loop. So as it goes down, it looks at the first 4 digits or first 4 characters of the hex code, and if it matches up with any one of these suppliers, then it will print that to the screen. Now, I happen to know that the code for the camera is using NEC. So what will happen is it looks at the first 4 characters, which I think is E0, E0, and it matches it up with NEC and prints it to the screen. And then it prints the results, the actual code of the button press. And it's got supplies in for a number of different manufacturers, or codes in for different manufacturers. And if it can't find a manufacturer, then it'll just print unknown. So what I'm going to do now, I'm going to open up the serial monitor, and I've got the Samsung remote control. I'm going to press button 1 on the Samsung, and I'll press button 2. Now you see what happened there. When I press button 1, I was quick, and it just gave me the code and these manufacturers. But when I press button 2, because I left my finger on it a little bit longer, it printed out the code 3 or 4 times, 3 times I think it is. Some remote controls, if they see the same code, they will print FF all the way along here. So sometimes you might see, if you left your finger on the button for a while, you might just see a series S. It just means it's repeating the code. So you can see though that the E0, E0, that's the manufacturer's code, and that was what's matched up in the script, and it presented the name of Samsung. Now I've got my sky control here. I'm going to do the same thing here. So I'm going to press button 1. So you see now, the code is a bit smaller, but C05C is the manufacturer code for RC6. So Sky not using their own decoder set, they're using somebody else's called RC6. But you notice the data is smaller, where before it was for the remote control for 1, it was 20DF for the Samsung. For the Sky control is just 01. And if I press button 2, it's 02, which kind of makes sense really, because that's button 1, that's button 2. And I'm guessing if I press 3, that's going to come up as 3, and it does, and 4 will be 4. Yeah. So that's the script that we're going to be using. What I'm going to do now, I'm going to go back to the church and run this program through the remote control of the Ava 520 box and record all the codes I'm going to use, and I'm going to start setting it all up. I've been to the church and I've recorded all the codes that I'm going to need. I'm now back at home and I'll just set up a bit of a test rig. I want to test the concept of this I2C protocol to see if I can get the Raspberry Pi to talk to the Arduino. So I'm going to jump onto the computer, put a bit of code together, and we'll see if this all works. So this is how I got my test rig set up. I have my Raspberry Pi connected to Arduino using the I2C protocol. So pin 3 of the Raspberry Pi goes to pin A4 of the Arduino. Pin 4 of the Raspberry Pi goes to pin A5 of the Arduino, and pin 14, which is ground on the Raspberry Pi, it goes to the ground pin of the Arduino. On this side of the Arduino, I've got infrared emitter or sender or transmitter, whichever you want to call it. One leg is connected via 150 ohm resistor to pin 3. Now it has to be pin 3 because that's part of the library, so we can't change that. And the other wire goes to just the ground wire. So that's how I've got it set up. Okay, I'm on my laptop now and I've got two windows open. The first one is the Raspberry Pi window, which is a virtual connection by VNC, and I have the Arduino window open, and that's connected to the laptop by a physical USB connection. Now the reason I've got both on the screen at the same time is that once I get this program running, you'll be able to see data leaving the Raspberry Pi and appearing on the Arduino. So that's the reason why I've got both these windows open like this at the moment. Right, so going back to the Raspberry Pi code, I'm using I2C, so before I can use that I have to have it enabled on the Raspberry Pi. And to do that I need to go to the desktop, I need to go to preferences, I need to go to Raspberry Pi configuration, and I need to go to interfaces, and I need to make sure I2C is enabled. By default it's turned off. In fact, by default all these protocols are switched off. So once I've got it enabled, I can start to use the I2C protocol. So first of all I need to do is import the library, which is called Symbus on the Raspberry Pi. I need to set the address of the I2C to be, I'm going to use 8 in this case, and I'm going to use Symbus 1. Now the Raspberry Pi has two I2C buses, one's called Symbus 1 and one's called Symbus 0. You can't use 0, 0 is for internal purposes only, so you have to make sure you're using 1. And all I've got here is a little while loop that basically asks me for some input, asks me for a number between 1 and 3. If I type in 1, then it's going to send out the hex value of 1 over the I2C protocol. If I send out the value of 2, it's going to send out a hex value of 2, and if I type in 3, it's going to send out 3. And it's as simple as that. So if I now go over to the Arduino code or sketch, the first line of command is calling up the I2C library, which on the Arduino is called wire. I'm also going to use the IR remote library because I want to be sending infrared information this time rather than receiving it. So I set up an object called IR send. We're going to be using the address of 8, which we did on the Raspberry Pi, and we're going to assign the variable receive event to the receive function of the I2C protocol. We're then going to set up the serial monitor and display information that comes into it. I've got a slight delay there just to let things settle down. And now we've got this while loop, and the while loop is while we're receiving data. Any data that it receives we transfer to a character called C. So as the information gets transferred from the Raspberry Pi, we read it and assign it to the variable C. Now if the variable C is 1, then it will send out this infrared signal, which is the Ava 520 camera code for button 1. And you see it's got, this is the code here, so 0x means it's going to be hex, and this is the hex value, and a comma, and then 32. 32 is how many bits it's going to be sent, because the I2C protocol or sorry, not the I2C, the infrared protocol uses 32 bits, or it can use 12 bits, or it can use 24, depending on the supplier. Now, there are tables on the internet where you can look at that tells you what how many bits each manufacturer uses. And in fact, in the DroneBot Workshop, Bill has got a list of all these things. So if you go to his site, as I said earlier, he'll have a list of manufacturers and their bit rates. So if I receive the character of 2, then I send this infrared command. And if I receive the value of 3, I send this infrared command. That's all it is. It's just a simple test program just to make sure that I send stuff from the Raspberry Pi and I'm receiving it via the Arduino. So let me get back to the Raspberry Pi. I'm going to run this code. And remember, all it's going to do is going to ask me for a character between 1 and 3. And if I send a 1, it should appear on the serial port of the Arduino. So let's try it. So 1, enter. There it goes. I receive it. 2, enter. I'll do 2 again. 2, enter. 3, 1, 3, 2. So I'm sending data via the Raspberry Pi and I'm receiving it via the Arduino. So let me get back onto my desk and I'll try seeing if it actually sends out the relevant infrared codes. Okay, I've modified the setup slightly. I now have another Arduino acting as an infrared receiver, and it's connected to the computer on the left, and the serial monitor is open so I can see any data that's been passed through to it. The computer on the right is running the Raspberry Pi script that I just demonstrated. So what I'll do is I'll go to the Raspberry Pi or the keyboard on the right, hit a few keys, and let's see if it actually transmits data. So I'm pressing 1, enter. The light flashed, and yes, the serial monitor received that and it's correct data. Pressing 2, 3, 1, 2. Yeah, so that's working really well, in fact. So I'm quite happy that the whole concept works. So what I probably need to do now is start thinking about creating a front-end program for the Raspberry Pi and also putting the codes into the Arduino. I'm not too happy about having 2 power leads. I need to do something about that. I've got an idea of what I can do, and I also need to find the enclosures to put this stuff in. So the next time I come back online, hopefully I'll have a working solution, a final product, and we can see it working. So it's been a few days since I made my last recording, and as you can see, I've finished the graphical front-end program. It's nothing more than just a window with 10 buttons, one for each of the camera positions. If I activate one of the buttons with a double click, it sends a message to Arduino, which in turn transmits an RF signal to the camera. I've also added some pan, tilt and zoom controls at the bottom here, just in case I ever need them. But before I go through the code, let me show you the hardware because I've optimized it somewhat. So when I was looking around for an enclosure to house the Raspberry Pi and Arduino, I found this Model 2B, which I've forgotten I had. It's not as powerful as the Model 3 or 4 and doesn't have Wi-Fi capabilities. But that's not really a problem because my application doesn't use a lot of processing power. By using an external Wi-Fi dongle, I can get a Wi-Fi connection. But what attracted me to this case was it has a removable lid and a compartment above the circuit board. This got me thinking that if I purchased a Uno Nano, I might be able to get it to fit inside the case with the Pi. So I purchased 3 nanos for £10 and I hot glued one inside the case. Let me take the lid off and I'll show you what I mean. I'm probably going to have to move the camera a bit closer so you can get a better view. That's better. You can see the Arduino Nano now more clearly sitting inside the Pi case. The Nano has all of the features of its big brother, the Uno, but with a much smaller footprint. It also uses very little power. So I was able to connect it directly to the Pi, 5 volts and ground pins here and here. As you can see, it fits in quite nicely, with even space for connecting the infrared emitter cable, which I've mounted on one of these crafting sticks. The idea being that it was sliding under the camera base. Let me show you what I mean. Imagine this box is the camera base. It has 4 feet, and the emitter was sliding underneath the camera and the brackets that are mounted underneath it. So that's our plan. That's the camera base. This will slide underneath it. the infrared receiver is about here on the camera. So it's right in front of it, so it should be no interference. So that's the plan. I'm going to pack it all up, take it to church, but before I do, I'll just go through the programming code in a bit more detail. Okay, this is the Python code that I use on the Raspberry Pi. To be honest, it's very straightforward. A lot of it is repetition. But let's start from the very top. We're going to open up two libraries. One is the TK-Inter library, and the other is the SM Bus library. TK-Inter is the library that allows me to use the graphical user interfaces, the buttons and such like. SymBus is the bus for using the I2² protocol. And we're going to give the bus the address of 8 or 08. And on the Raspberry Pi there are two SM buses, but we're going to use one. 0 is reserved for internal purposes. I'm then going to set up an instance of TK-Inter. I'm going to use the variable win. I know a lot of people tend to use root and some use screen, but I just prefer to use win. Then I'm setting up the geometry. So basically I'm setting up the main screen that all the information is going to be displayed on. So the width is going to be 900, the depth is going to be 500, and I'm going to position it 30 in from the left and 95 down from the top. That's the window. Then I'm going to give it a title, Church Infrared Transmitter. Then I come to these functions. I'm going to come back to them in a few minutes. The next block of code is nothing more than just placing labels on the screen. The first one is the main label for the camera control. I've given it a larger font of 14 and I've made it bold, and I've placed it X location and Y location. X is 45 from the left and Y is 30 down from the top. This next block is code is nothing more than just placing the numbers for the buttons really. So if I explain what I mean, if I click on the run button, so it's these buttons here. So it's these designations here: 1, 2, 3, 4, 5, up to 10, pan and tilt, zoom, and this command here. That's all those labels. That's all it's doing here, just placing them labels on the screen. Now the more interesting bit is the actual buttons themselves. So I've got 16 buttons. So button 1, let's go through that first of all. The first thing you do is you place text on the screen. So I've got Alter Wide View. Now I've hard coded doing all the designations for the buttons. Eventually I will make them variables, and I'll have it so the user can change the designations simply by just a few keystrokes within the program. At the moment, if I've got to change them, I've got to go into the program itself and hard code it. So that's temporary. Then it's the height of the button and the width of the button, and then command. What do I do when I press the button? Well, it's going to go to camera function 1, which I'll come to in a second. And the last command is, where do I place it on the screen? So I'm going to place this button 30 in from the left and 100 down from the top. So let's go back to the command function. So when I click on the button, this part of the code will run. So the command is equal to camera function 1. So if I scroll back up to the top and look at camera function 1, it does nothing more than write to the bus the hex value, because 0x it tells the program it's going to send out a hex value. So it's sending out a hex value of 1. Camera function 2 sends out a hex value of 2. Function 3 it sends out a value of 3, and so on. Except when we get to 10, and because we're doing hexadecimal, you can't send out a 10. You've got to send out a. So when camera function 10 sends out an A, camera function 11, or in this case camera tilt up, sends out a B, and so on. And that's basically the program. The very last thing to show you is you need to make sure, forget about this piece of code here, as I've been playing around with symbols. You need to make sure you've got the win main loop in there. If you don't have in there, the program won't stay open, and it'll close straight away. In fact, you won't even see it open and close so fast you don't think anything's happened. So you must have that win main loop in the program right at the very end. Okay, so let's go and have a look at the Arduino code. Okay, this is the code for the Arduino, and to be honest, it's exactly the same piece of code I went through last time. I've just extended it, to be honest. But before I go through it, let me just say that any code that you see on this video is available on my GitHub page. So there's a link in the description below. So if you want to download it, play around with it, change it, do whatever you want with it, no problems with that. It's available from GitHub, and the link is in the description below. Okay, let's quickly go through this code. The first thing we're going to do is going to download a library called Wire, which if you remember is the library for the I2C bus. We're going to download the IR remote library, which is the library that sends and receives infrared signals. We're going to set up an instance of IR send because we're actually sending out infrared rather than receiving it. We're going to be looking on the bus for anything that has a value of 8. If we do see it, we're going to assign it to the variable receive events. And we're going to open up our serial monitor here. Then we're going to put a delay of 2 seconds in just to let things settle down. And then we're going to go through the loop and we're going to start looking for data. If we see any data, we will print it on the serial monitor, but we won't worry about that just now. If we see a 1 on the bus, then we're going to come down to here, and the first thing we're going to do, we're going to send out this command here. Now the first line of this command is the program button on the remote control, a delay of 1 second, and then we're sending out the actual location code. Now remember I said that the remote control needs 2 keystrokes. You have to press the program button and then the location key. In this case, if I see a 1, I send out the program button command and the location for keypad 1. If I see a 2, I'll send out the program button command and the location key for keypad 2, and so on, all the way down to I think it's 15, and that's it. That's all of the code. So nothing more to do now then. Pack everything up, take it to the church, and let's try it out. I'm back at the church now and I've installed all the equipment, including the infrared emitter, which is just sitting in front of the camera. And if you look carefully, you can see it's just left of the blue light. And everything seems to be working really well. So if I zoom out to where I normally sit and zoom back in on my iPad, you can see the graphical user interface that I created. And that's working really well. Just move the cursor, double click, and it's a button, and the button's actually making the camera move. You can't see that at the moment, but I'll show you that in a second. So if I now zoom back to the camera, get focused in a little bit closer. Yeah, you should be able to see it move. So if I do, I'll go to the prayer card straight away. See it moves. Main lectern. Reader's lectern, priest's chair, wide angle view, and the baptism funerals. Yep, so it all seems to be working really well. So that's it really. I'm going to try out our next mass, which is this weekend, and hopefully it'll work as designed. So look, thanks for watching this video. I'll just mention again that if you need to download any of the software that I use on this project, then you can do it from the GitHub. Link is in below. And thank you for watching. Really appreciate it.